Bapak Ibu semua. Okay, so we'll be covering now 17H selections with and without replacement. Okay, so we have done this before, previously in Sec 3 and Sec 4. Okay, so this is on page 538. The first part will be the understanding part. Okay, and then we'll cover one work example, and that's for 17H. Okay, so for understanding with and without replacement, the concept is quite easy. Okay, for with replacement, you can see this particular tree diagram over on page 539. Okay, page 539. So this one is page 539. Okay, but the one without replacement, it is the tree diagram is available on page 538. Okay, so it's like swap, okay, one and another. Okay, so let's read the story. Okay, to understand the story, we have to look up at page 538 first. Okay, suppose you have a box containing 10 white and 10 dark chocolates. Okay, and you pick 2 chocolates without looking. Okay, we can think of this as 2 events happening, one after another, even if the 2 chocolates were taken out in one go. Okay, and draw a tree diagram to show the outcomes of each event and their probabilities. Okay, what's the probability of both chocolates are white, or for the first chocolate, the probability of getting the white. Okay, so let's run through this. Okay, this one, when we say that we take 2 at one go, okay, will be the one that is without replacement. Okay, because you didn't put it back, you just take 2 at one go. Okay, so the probability that the first one is white is 10 over 20, or the first one is dark is 10 over 20. But when it comes to the second one, okay, since you didn't replace it, if your first was white, okay, the number of white chocolates will decrease by 1. Okay, so now instead of having 10 white chocolates, we now have 9 white chocolates. Okay, and the total number of chocolates also decreased. Instead of 20 chocolates in total, we now have 19 chocolates. Therefore, the probability of getting a white chocolate on the second trial is actually 9 out of 19. Okay, for the dark chocolate, it still remains as 10, so it's 10 out of 19. The total having changed to 19 now. Okay. Similarly, if the first chocolate was a dark chocolate, okay, then the probability of getting a white chocolate in the second trial, okay, since the white chocolate was not taken out, it still remains as 10. Okay, but the total is still 19 again. So now the white chocolate for the second trial, for this case, is 10 out of 19. Okay, but for the dark chocolate for the second trial, it means dark and dark. Okay, the dark chocolate has been taken out, similar to the white example. Okay, so it is now 9 dark chocolate left, okay, and a total of 19, so 9 over 19. Okay, this is when you do without replacement. Okay, but sometimes when you read the question, okay, when you look at page 539, okay, they actually create another one, okay, whereby we call it selection with replacement. Right? Okay, so selection with replacement, the tree diagram is over here. Okay, so you take out the first chocolate first. Okay, if it is white, you take note of it. Okay, and then you put it back. Okay, and then after that, you take the second chocolate out. Okay, so by doing so, you did not change the total for the second trial. Okay, so the total still remains as 20, and the number of white chocolates still remains as 10, even though your first draw was white. Okay, so the probability remains the same throughout. Okay, similarly for the probability of dark chocolate, it was originally 10 out of 20. Okay, whether you draw a white chocolate in the first trial or you draw a dark chocolate in the first trial, it is still going to be 10 over 20. It doesn't change. Okay, so these are the 2 different cases. We'll look at the work example to see whether you understand this. Okay, so I'll erase this and change it to the work example. Alright, welcome back. So I've changed the tree diagram. Okay, over here, G will represent green, Y will represent yellow. Okay, let's read the question first. A bag contains 7 green and 5 yellow balls. Okay, 2 balls are selected at random, one at a time. Find the probability that the 2 balls are of different colors if the selection is made. Okay, part A we have to do with replacement, which is over here. Okay, and part B will be the one without replacement, which is over here. Okay, so we'll do it together. Okay, so I've put in the probability for the first child. Okay, so for the first draw, there are 7 green and 5 yellow balls. So there's a total of 12 yellow balls. Sorry, 12 balls. Okay, so probability of getting a green will be 7 out of 12. Probability of getting a yellow will be 5 out of 12. Okay, if we replace it, okay, the second trial, the probability will still remain the same, okay, because no changes in the number of balls or the number of a particular colored ball. Okay, so 7 out of 12 over here, 5 out of 12 over here. Okay, similarly 7 out of 12 over here, and 5 out of 12 over here. Okay, so you want the probability that the two balls are of different colors. Okay, all you have to do is find probability of GY in different color and probability of YG. Okay, so that is given in the question. GY is given as 7 over 12 times 5 over 12, and then YG will be 5 over 12 times 7 over 12, and we add these two probabilities together. Okay, which will leave us with 35 over 72. Okay, or 0.486. Okay. Right, now let's take a look if it is done without replacement. Okay, if it is done without replacement, okay, the tree diagram will be as such. Okay, let me go over here. Okay, this is the tree diagram for without replacement. Okay, the first trial is the same. Okay, because nothing happens. Okay, but for the second trial, okay, the probability will change. Okay, first, the total number of balls will now become 11. So, for if you take out the green, there are 7. Okay, we will now left with 6 over 11. Okay, if we take out the green, the number of yellow is still 5, so it's 5 over 11. Okay, so likewise, for the second part, if you take out the yellow, the green will remain the same as 7, but the total is still 11. Okay, and then for the yellow, it would be 4, because it is originally 5, but you took out the yellow and you didn't replace, so it's 4 now. It's a 4 over 11. Okay, so looking at the tree diagram, if you want to see the GY and the YG, the probabilities will be different. Okay, so probability of different colors would be 7 over 12 times 5 over 11. Okay, not the same as just now. Okay, and 5 over 12 times 7 over 11. Okay, and you find the probability of different colors. You can see from the book, it will be 0.530. Right? Okay, so that's the work example for 17H. You can now try your homework. Okay, so remember, teachers don't just teach professionally, teachers teach professionally.